Hi, I'm Tom. I'm the owner and director of Robotic Vision. We're the designer and manufacturer of the Ofda fibre measurement instruments. In this video, I'll be going through the Ofda2000s and how to use them in their various measurement modes. The Ofda2000 is designed for easy setup and usability. Let's start with the connectors. For the benchtop model, all of the connectors are on the back panel. The power connector can go into either port. Make sure to tighten the locking ring. If the power is on, the internal white light should also turn on. If you have the older model, a green light on the control box will turn on. For the portable model, the connectors are all on the front of the control box for easy access. Just like the benchtop, you can plug into either port. Just make sure the locking ring is tightened. The background lights behind the control box and the front-facing green light should turn on when the power is plugged in. Next, connect the USB cable. For the portable model, you can place the cables over the cable management hook to keep them out of the way during use. The USB cable goes from the Ofda straight into the computer, not into a hub. Try to limit the number of USB accessories connected to the computer to avoid overloading the USB bus, which could negatively impact the Ofda's operation. Once everything has been connected, start the Ofda program. This will take you to what we call the blue screen. The blue screen is designed to give you all the information you need at a glance. The most important information is all in the top left corner in the diameter section. Mean is the average fibre diameter in microns for that sample. CV and SD are indicators of the distribution of the sample. Comfort factor is the percentage of fibres under 30 microns. And the number of fibres is how many fibres were used to calculate the above metrics. In the curve section, the number of fibres refers to the amount of fibres used for that curvature measurement. The mean is the average curvature of that sample in degrees per millimetre. The instrument section shows information about the Ofda. The number of fields is how many images were used to analyse in that measurement. Focus is how sharp the image is. More on this later. Density of fibres is critical for monitoring the quality of the sample preparation. Also, more on this later. At the bottom of the screen, you can see the histograms for diameter and curvature. For the diameter histogram, the horizontal axis is displayed in microns, whereas the vertical axis shows the current count of how many fibres were measured at that particular micron. The first mode of operation we will look at is called clean snippet mode, or commonly referred to as 70mm glass slide mode. It is designed to be used with clean fibres. The concept is to prepare a sample by distributing fibre snippets onto a glass slide, where the individual fibre snippets can then be measured. Fibre snippet mode was originally developed with the Ofda100. The Ofda100 is the first Ofda instrument. By cutting and spreading these fibres, it allows us to see many individual fibres and gather large amounts of data in a short time, increasing the accuracy and repeatability of measurements. The guillotine is used to cut fibres into snippets. It is a precision engineered accessory. Over time and with use, the blade may become dull. If you need a replacement or an upgrade, please let us know. The latest model features a magnetic tray that locks into the frame. However, older models will use a stainless steel tray. Both options work well. To use the guillotine, place the appropriate amount of fibres into the device and push down. The fibres will fall directly into the tray. Between every sample, the guillotine should be thoroughly cleaned to avoid cross-contamination. A vacuum is the best method. Make sure you clean everywhere, including underneath where fibers can accumulate. After we've cut the snippets, we need to be careful of the way they are handled. Too much agitation or movement and the fibre snippets can fly away. This is especially critical for fine fibres like merino wool and cashmere. We want to use clean tweezers to select a sample. If too much sample is picked up, do not tap it to drop some off. This can bias the measurement, as the coarser, heavier fibres are more likely to drop off, and the finer fibres are more likely to fly away. Instead, use tweezers to pry the fibres apart into good amount. The spreader is used to evenly distribute the fibre snippets onto a 70mm glass slide. Plug the spreader into its dedicated power supply, making sure to tighten the locking ring. Next, place a glass slide underneath the spreader. Place the appropriate amount of sample into the spreader. Then press the green button to start. Ensure all of the fibres have fallen through before stopping the spreader. Coarser fibres fall through much quicker than finer fibres. Stopping the spreader early will bias the measurement. Over time, the steel mesh may wear down and need replacement. Check the mesh by feeling it. It should feel rough around the holes. If it feels smooth, please contact us for a replacement. It is also critical to clean the spreader between tests to avoid any cross-contamination. Ideally clean with a vacuum with a nozzle. Make sure to get into the sample area as well as underneath. The glass slides are made from specially sourced glass that is extremely flat. The thickness of the glass is set to a very tight tolerance of 50 microns to ensure consistency and avoid any focus issues. As a glass slide is used, it can develop scratches from sand and dust. These scratches can sometimes resemble fine fibres. To avoid any potential biasing of measurements, slides should be discarded when they show signs of wear. After a glass slide has had a sample distributed, be very gentle when closing the slide. If the slide is closed too quickly, fibres can fly out and bias the sample. Every piece of glass is checked for size, thickness, and scratches at the factory before it is approved for use. Contact us to source more if you need it. To achieve the most accurate measurements, we want the fibre count to be as high as possible, so the Ofda has the most data to work with. With practice, operators will develop the skill to estimate the appropriate sample size. The amount of fibre needed will vary depending on the micron and fibre type. The density of a 70mm mode measurement should optimally be between 10 and 25% to give the highest fibre count. The density of a slide is dependent on how much sample is placed into the spreader. If not enough sample is placed into the spreader, the slide will result in a low density and inaccurate readings. However, if too much sample is placed into the spreader, it will result in the fibres being tightly packed. This leads to a lower fibre count, as individual fibres cannot be distinguished by the Ofda. With practice, operators will develop the skill to estimate the appropriate sample size. The amount of fibre needed will vary depending on the micron and fibre type. Do some tests with your fibres to find what is best. A slide adapter is used to hold the prepared glass slide. The 70mm adapter magnetically couples to the stage. When installing, ensure both the stage and adapter are clean and there is no debris under the feet. To use the adapter, push down on the hinge while inserting or removing the slide with your other hand.
This is an example of the Ofda with its fibre snippet mode using the 70mm glass slide. So here I have a sample of wool sliver. So I'm going to chop this up with the guillotine. This is thick enough where one firm cut is enough sample. So that gives us some sample here. Then I'm going to put the slide into the spreader. I'm going to carefully put the appropriate amount of fibre into the spreader. I'm going to start that. This wool is quite fine, so it won't take very long to spread through. I'm going to very carefully close the glass slide before putting it into the adapter. From there, you just hit the spacebar on the laptop, where you can then put a sample ID in if needed. In the meantime, I can vacuum up the accessories. Measurement takes roughly 30 seconds and will do between 10 and 20,000 fibres measured. That's the slide completed, and we can also vacuum that off, ready to go again.
Fiberglass slide mode was originally developed for measuring greasy, mid-side samples inside the shearing sheds of Australia. Since there is no glass to smudge, there is no problem with using dirty or greasy fibres. The slide itself is made from fiberglass because it is an extremely durable material. They magnetically latch shut and also magnetically lock to the stage. Your set of slides are matched to each other to ensure a repeatable focus. The preparation fan is used to hold fibres in place when laying them onto the slide. It also helps dry any fibres that contain moisture above atmospheric conditions. It can be opened to be cleaned, and you can turn the fan on or off via the switch on the back. The power plugs into the Ofda control box. Don't forget to tighten the locking ring. The most common use for this measurement mode is to be able to see the average micron along a length of an animal staple. We know as conditions change, micron can also change. Factors like weather, feed levels, and stress can affect the micron during the year. By laying the sample in line with the tip to the top of the slide, it allows us to see this profile change and use this data to either feed back into production or to give us information such as mid-break potential in later processing. We create micro staples by pulling apart a staple and then laying them in. We want a good, even spread. Fiberglass slide mode gives a unique measurement result. This is the diameter along the staple. This shows us the average diameter at a certain distance along the sample. This graph is potentially the most critical feedback for growers, as it can show how the micron changes during the year, how autumn versus spring shearing affects the profile, and even how wool will behave in later processing with its mid-break potential. In this example, we can see an average of 15 microns at the tip, around 19 microns in the middle, and 21 microns at the end, 65 millimeters from the tip. This shows us how relying on a single micron average for a whole staple can be misleading when a true representation of the sample is desired. This mode isn't just for wool. We can use this with any fibres to calculate the micron and curvature without the preparation needed for the 70mm mode. This measurement mode provides a quick and easy way to measure fibres like hemp, alpaca, or even non-wovens. Just like the 70mm mode, a good density level will increase the fibre count, which gives a more repeatable and accurate result. The ideal method of laying out the fibres and how much to put down depends on your specific fibres. We recommend trying with less, then increasing the amount until you see the fibre count drop. This will give you a goal fibre count to work towards. When grease naturally forms on animal fibres, they appear bigger under the machine vision view. We need to subtract this amount of grease to get a true micron value. The amount to subtract is known as the GCF. The amount of GCF depends on the type of animal and may also depend on how coarse the fibres are. Further details and the method to obtain GCF will be outlined in detail in another video. Just like when you take a photo with your phone and it needs to focus on what you're looking at, the Ofda needs to focus on the fibres. To do this, the arm moves up or down to the correct distance away from the fibres. On the blue screen, there will be a focus number. The optimal value for this number depends on a few factors, such as the model of Ofda and the diameter of the fibres you are measuring. However, a lower number is always better. The better the focus, the more fibres the Ofda is able to see and will include in its measurements. The Ofda is able to automatically set its focus level. To do this, follow the on-screen instructions. The best way to open Meswin is to go to the Ofda program, File, then open File in Meswin. This will link the Ofda and Meswin programs together. All of your Ofda measurements are saved into a Mes file. This is a text-based file that contains the data from your measurement. In Meswin, you can go back and look at previous Mes files. Meswin allows you to export and save reports containing the results and histograms from your measurements. There are many different options for what you would like to include in your reports, but to save, go to File, then Print. It is also simple to export your data in a CSV format. This can then be opened in Excel or connected with any custom software solution to suit your needs. This is especially useful for researchers who wish to further analyze the data. To get a CSV file, go to Convert and then Start. We always recommend to save your data in more than one place. The Ofda will save its results wherever the Mes file is located. We recommend taking advantage of using cloud-based storage solutions such as Dropbox or OneDrive to automatically back up your data. If this is not possible, always back up your data in another location, such as a portable USB hard drive. The Ofda needs very little maintenance. However, it is recommended to keep the instrument clean from grease and dust. Any contaminants on the glass optical surfaces may affect the focus or image quality. Use a soft brush and Windex or a common glass cleaner to keep the glass clean. Make sure not to scratch any of the glass. Every 6 months to 1 year, the bearings should have a small amount of oil put into them. The best way to do this is to place 1 or 2 drops on the linear rods and then move the arm backwards and forwards. Use a multi-purpose light machine oil.
Thanks for joining me for a look at the Ofda2000. If you have any questions or inquiries, please don't hesitate to reach out or have a look at our website, Ofda.com, for the latest news and updates. I'll see you next time.